Essential oils can be extracted from plants by steam distillation at a temperature below 100. So I explained to you this distillation. You have to mainly do steam distillation and fractional distillation. Fractional distillation we use for crude oil for the separation of kerosene, petroleum, and all those things. However, to extract oils from plant oils, for an example, cinnamon oil, citronella oil. So those oils we need to go for a steam distillation. Why? First thing is when you do steam distillation, according to its theory, the distillation process happens below even a temperature below the boiling point of water. That means temperature below 100. So these components, these oils, if you use higher temperature, they will decompose and you will not get the proper oil. So it is necessary that you use a lower temperature and extract really well, right? So essential oils can be extracted from the plants by steam distillation at a temperature below 100. So this is correct. This is based on our theory. Okay. At the temperature at which a mixture of essential oil and water boils, the total vapor pressure of the system is not less than, it is higher than the atmospheric pressure. That is our theory. So this is wrong, right? So I wanted to explain the theory also a little bit because you might have not learned this one. So just a brief explanation from my note. So steam distillation applications to extract basically the oils and some of the organic compounds, okay, which are not mixed with water. That is the important thing. If it is mixed with water, you can't do steam distillation. You should go for like a fractional distillation or some other concept. So the advantages: can obtain components below its boiling point without decomposition. That is one of the major advantages. And the fractionation do not mix. So I have given a few advantages you can go through. So what is the principle? This is the important thing. So compounds that do not mix and having boiling points greater than water or around boiling point of water, which can be decomposed at higher temperature, needs to be separated, and we use steam distillation for that. So this is the idea for using. I told you. For an example, if you have a nice good essential compound like a good oil, so if you think that using a higher temperature like 300, 400, or either more than 100 like 130, 40, if it is, you think like, okay, that might destroy our compound and you don't get a good oil, then you have to go for a method where you can use a temperature lower than 100, even temperature lower than 100. So then it comes the steam distillation. Okay, so let's consider the separation of cinnamon oil from cinnamon leaves. Okay, so when steam is supplied and the mixture get heated, okay, at boiling point, the total pressure is equal to the absolute pressure of both water and both oil. So try to understand this first. Why I have put P naught H2O and P naught oil, not PH2O and P oil, like in the fractional distillation, like in the Raoult's law. Why? First think about that. The first point that should come into your mind is these two are not mixed. Okay, so these two are not mixed means these two are behaving like two different solutions that is present and that is evaporating independently. Okay, if you remember in Raoult's law, the molecules are mixing. That is why there was a vapor pressure depth, right? But here these molecules are not mixing. So there is no vapor pressure depth because these molecules are still behaving as they are present in the solution as alone, and they will evaporate with their absolute vapor pressures because their mole fraction here is 1, because they are only existing and they do not mix. Therefore, the total pressure of the system here is the absolute pressure of both components. Okay, so reversibly, the boiling point should be lower than even the absolute pressure of water and absolute pressure of oil. Why? Because think, if you have only water in a solution, you evaporate it, right? So water molecules get evaporated. And at 100 degrees Celsius, you have this boiling. Now here, you have water as well as oil. So when you heat it, water molecules also evaporate independently. Oil molecules also evaporate independently, and it also will contribute to the vapor pressure. So in which case that will participate to a minimum time to get this boiling? It is with water plus oil, because if it is only water, you need to heat it at 100. But here, since water and both oil are evaporating, you don't need to heat up to 100. It will come to equal to atmospheric pressure within 80 degrees Celsius, because both are evaporating at its absolute pressure. You see? So now what will happen is, this boiling point will happen even a boiling point that is lower than water or even lower than the oil. So that is the major advantage and the concept behind this steam distillation. Okay. So this is the idea. Since water and oil do not mix, behave independently and vaporize its absolute pressure, so the total pressure at the boiling point is the absolute pressure of water and oil. Therefore, the temperature, the boiling temperature will be very lower even than the boiling point of the component which has the lowest. For an example, if water is 100, this is 120, the boiling solution will be lower than 100. That's the idea, right? I hope you understand this. So that is what here it indicates. It will boil below 100, and the total vapor pressure is not less, it will be higher. Okay. Yeah, this is a concept that is misbehaved. So you see, at the temperature with the mixture of essential oil and water boils, the total pressure of the system is less than the atmospheric pressure. This is not mean less than the atmospheric pressure. This should be equal. That is what we say the boiling happens. Okay. So don't panic, misunderstand this one, because when the vapor pressure equals, it will boil. Okay. When the vapor pressure equals the atmospheric pressure, it will boil. Okay. That is the idea, right? So this is not less, this is equal. Okay. What I am trying to tell here is, it will be normally the vapor pressure will be contributed from both water and the oil. Therefore, the total vapor pressure will be very high in the vapor phase, allowing the boiling point to be even lower than the water molecules. Okay, so don't try to get stuck with that. So here, rest of the concept. So PT is greater than P naught H2O. PT is greater than P naught oil, so that the mixture boils at a temperature below to the boiling point of water and oil. Thus, oil can be obtained without any decomposition. Okay. This is one of the additional points that I have written even in my notes. In calculations, since the composition of the fractionate and the composition of the vapor is same. Why? Because both are independently evaporating. So you take the fractionate and you get the composition of the fractionate as well as the solution. It will not be different, right? Any information given for the fractionate can be considered information of the vapor. That's it. You understand my point? Because in Raoult's law, you evaporate, one of the components escape fast, the other component escapes slow. So the composition of the vapor is different from the composition of the liquid. But here, that is not the case. Both are same. So if something is given for the liquid, you can take that as for the vapor, and you can use the Dalton source for the vapor. Dalton law for the vapor. OPV equal nRT for vapor. Okay. That is the simplest idea that I can give you.